Hello, 3D modeling class. It's week 12. You can see I'm in a little bit of a new setting here. I moved, and there's quite a few boxes around me. A bit of a mess. Today, our topic is a little bit of a trickier thing, and you may not understand the value of it at all. But it's a cool thing. If you can kind of wrap your head around it, it can be a very powerful technique in the world of 3D, and that is geometry nodes within Blender. So last week we kind of talked about procedural, or one way that I think of procedural modeling to use simulations to model things. But there's this other form of, and this is maybe the more common. When someone says procedural modeling, this is maybe the more common thing people think of, and that is with geometry nodes. And it's everything that I'll show you, or like to introduce this to you. Everything that I'll show you is something that can also be done with like traditional modeling, but it allows you to kind of combine things and sort of create formulas for creating things automatically that can be powerful and interesting. And it's maybe hard to understand what I'm even saying, so let's just get over to it. Let's just get on with it. Here we are in Blender. You may or may not have a geometry nodes workspace at the top here. If you don't see geometry nodes, just hit the plus button, and it's in one of these things. General, maybe. Yeah, geometry nodes. It should be in there. So let's go over to geometry nodes. This is, I don't even know what you call this particular, what is this called? Where is this on here? The spreadsheet. So this, this gets really nerdy. So like you can have like complex data sets here that you can use. For today's example, we're not going to use this, so I'm going to go ahead and select here and minimize this window. So we've just got our viewport, and down here our node editor for geometry nodes. Okay, so I'm going to delete the camera and the light here. Follow along with me. Select your cube, and we're in geometry nodes here, and I'm going to hit new. So the geometry nodes is a modifier. So it appears on your modifiers tab. So, and also like if you go here and hit add modifier, it's under, what is it under? It's under generate geometry nodes here. Also, just like a note, many of these things like generate and deform, these are just things that you play with and you learn what they do. Originally, I was thinking about going through some of these in detail, but it's like, you just got to kind of play with it and figure it out. But geometry nodes is maybe something that needs a little bit more hand-holding, which is why we're talking about it. So, geometry nodes. We hit new with our cube selected. We're greeted with a group input, and we have geometry, and a group output, geometry. Now, as I said a few moments ago, everything that you can do with traditional modeling tools is available to you here in geometry nodes. So if I go Shift A, look at all these different things. Like the simplest one would be like transform. So I'm actually even just going to search for transform because I don't even know where it would be. So I have a transform node here, and I can drop this right on top. And so like we have the geometry node going in to this transform node, and then we can alter these values and then have it output it to the output. So like if I change the X here, it's changing the X value. If I'm changing the Y rotation, it's doing that, etc. So like where the power comes in is now we have these empty sockets here that can impact these values. So, and maybe you can see that there's a lot of animation potential here as well. So let's just think of something like kind of silly. Okay, so how about this? So let me just change this translation back to 0. This this can all be 1, 1, 1, 1. Okay. So let's do this. So let's Shift A, and what am I looking for? Let's go into geometry proximity. Let's try this one. And we need another object in the scene here. So what I'm trying to do is I'm going to change the scale of this based on the proximity to another object in the scene. So I'm going to add a Suzanne in here. I'm going to go Shift A, add a monkey. Okay. Just move it over there. Okay. And so we're going to use the proximity from Suzanne to the cube to change the scale. So let's go Shift A, and I need a input, and I need to get the object info. So you maybe remember object info from other node editing shader nodes. Let's do and this is retrieving information from an object. So we're going to put this in here. And it asks us to select which object we want to retrieve the info from. So I want to choose the info from Suzanne. So I'm going to get the eyedropper and hit Suzanne like that. So now I want to get, let's see. We're going to put the location of Suzanne as our source position, and the geometry from Suzanne is our target. And then I want and faces, I don't think this makes a ton of difference. And then I want to make the distance, and this is gonna be kind of janky, but I just want to show you like kind of a silly example. I want to plug the distance into the scale like this. So this is like sort of doing the distance from Suzanne to the cube is going to affect the scale of the cube. So if I move Suzanne closer, it's going to get smaller, I think, until it gets to like 0, 0, 0 there. As we move away, it's getting larger. So you can see that, like, it's procedural. The scale of this is being procedurally altered based on the location of Suzanne. So this is like we're just starting to see the powers of this a little bit. So one kind of good example that I've seen other people on YouTube do is like creating a landscape procedurally. So let's walk through that quickly. So I'm going to delete these, delete this, delete this. Let's go Shift A, add a plane, scale it up, and let's add a new geometry node. And we're going to call this like we'll call this displacement. So you can use the same geometry nodes on other objects. So we'll show you that in a bit. So that's why we're giving it a name. So just like other materials, you can save materials and apply them to other objects. No geometry nodes you can save and apply to other objects as well. Because look, if I pull up geometry nodes here, this is the same one I did before. So this one is called like scale proximity. A scale, but we're not really going to be doing that. So displacement. Okay. What do we want first? So first, we can actually add a subdivide here. So you could add a subdivision modifier, but like let's make it all centralized. Let's do one, do everything in our geometry node. So I'm going to Shift A, and I'm just going to search here for subdivide. Well, okay. So I think we want subdivision surface. No, let's do subdivide mesh. Sorry, it's a little simpler. Subdivide mesh. So this is just like it just cuts things into fourths. So if we're in edit mode like this, we can up the levels of our subdivide 3, 4, 5, 6. Oh, and actually it's doing it. It's going to do it procedurally, so we're not going to see it here in edit mode. So just stand by with that. So remember back to when we did the ship renders, I used a noise. Whoa, losing my headphones. I used a noise material to kind of create bumpiness in here. So let's bring in a noise material real quick. Shift A. I think it's in material. I think just search for noise. What noise texture. texture, not material. Okay. But now how are we going to, because I think how we did it before was with the color or the factor, one of these two. But how do we get it to like be part of this geometry procedurally? So one thing we can do is we want to set the position of the geometry, relative, in its local space here. So there's a node that we'll add in here, and it's called set position. So actually, I should learn where these actually are. I think is it in mesh? It's sometimes it's easier just to search. Set position. Set position. Okay, and so we'll do this after we subdivide. So we're taking the subdivided mesh, plugging it into our set position here, and then putting it into the output. Okay, so we're getting close. So somehow we need to kind of alter the positions of this geometry with our noise texture. But it's not as simple as just plugging the position in like this. There's a couple of things. So we need to get a little bit more information from our object here. So we need another input. We need to go to input, and this we want position. So this is retrieve a vector indicating the location of each element. So if I go position like this, we can that plugs into there. And like each element, means like all the different parts of the geometry, not just like the object. So like we can put a math in here. So like I think if I just search math, we just put a regular math in here. You can, where'd it go? Maybe it didn't like that anyway. But I think one of the reasons it didn't like that is because the position here is a vector. So like regular math, a regular math node is like simple math, like adding two values together or multiplying two values together. In geometry nodes, we were using vectors, and vector calculates and includes the individual x, y, and z coordinates. So you can't, like, position here is x, y, and z. So you can't just take x, y, and z and say like multiply by 2. I mean, in the real math world, you can, but here, like, if you're working with vectors, you need vector math. So let's shift A, and then vector, you got a vector menu here, and we've got vector math. Great. So now we can take this vector here, and we can add, or we'll work up to that. And then so that we can do math with different vectors here, and then output that to the position. Okay, we're getting close. So let's just try this. Let's try taking the factor from our noise texture and adding it to the position of all of the different elements here. Let's just try it. Okay, crazy stuff is happening. Let me turn down our subdivide. So you can see here now that our subdivision is actually working. 3, 4, 5, 6. And on our noise texture, we can like maybe try turning down the scale a little bit so it just looks a little bit more natural. Okay, so let's analyze what's happening here. So we have a plane. Our plane has this geometry node on it. The geometry of the plane is first being subdivided 6 times. Then it's outputting this into our set position node here. And this is setting the position of every like element of the mesh. So like basically all of the like faces and points and things like that. We are taking the position of the object, we're inputting of all of the elements of the object, and we are adding a random number between 0 and 1 to it in every coordinate, x, y, and z. I believe is how it's working. And that added vector is then being put into the position. This node is setting the position on all of the geometry, and then the geometry is being output to our viewport and how we see it now. Okay, so let's play with our noise texture just a little bit. So we already played with the scale a little bit, so this makes it like way crazy. If you up the scale, you can turn down the scale. You can up the detail. Let's maybe even right click and shade smooth too. Detail. You can have less or more detail. Roughness. Roughness is cool. Distortion. What does this do? Whoa, whoa. Let's set that back to 0. Distortion is disturbing. Okay. So if we're wanting this to be like a landscape or like some sort of like yeah, landscape. Like say you want this to be like a map of mountains or something like that. It's still not doing what we want it to do because it's all kind of like going at an angle. So we can separate the vector here and work with individual elements. So notice how we're kind of mix matching socket colors here. We're taking the factor and plugging it into a vector. So and that's why this is all kind of going in the same direction, because the factor is outputting a value between 0 and 1, no matter what. And so it's putting that value into the x and the y and the z, and combining that into a vector. So there's a node that we can add here, Shift A, and we want, and it's in vector here, and we want to combine x, y, and z. So if we drop this one on the node here, you can see that this can input 3 different gray values and combine them into one purple vector. Right now it's plugged into x, so you can see that everything is just like smushed flat. But if you move this over to the z, you can see now that we are now just distorting in the z value. So you could plug this into x and the y and the z like that. And that'll bring you back to where we were, but we can disconnect this and this, and we just have the z. Cool, so this is like our little mountainscape here. Maybe we want a little bit more detail. Oh, maybe. Or like a little bit greater scale. A little bit smaller scale, maybe. Now, the other thing too with the factor is like, well, so here, let's add a color ramp. I'll show you what this does. So Shift A, search color ramp, and drop that onto here. And so, color ramp also can input. So, values from 0 to 1 also are values from white to black. So Blender can interpret that in either way. So like a color ramp by default is a scale, a random, not necessarily random, but it's a scale from black to white. So if I bring down, if I bring up the black like this, you can see that it starts to like sink down, and eventually like parts of it gets like flat on the ground here. Same thing with like the white. If I bring the white way up high, like it's gonna stretch and eventually flatten out at the top here. Because this is, if I'm not mistaken, this is between 0 and 1 meter in our position here. So like you can bring this way down here, and it's smushing it down. So like yes, technically we're outputting a color and putting it to the Z, but like it's interpreting this as values between 0 and 1. So like this is 0 down here, or also known as black, and this is white up here, also known as 1. So now it's starting to be kind of an interesting little mountain range here, you know? Okay, next thing, on our noise texture, right now this is 3D, let's change this to 4D, and this gives you one other input, and the W here is sort of like your random seed that you can change over time. So you can have different effects, but still kind of keep your same height parameters and stuff like that. So you can set this back to 1. Okay, now here's where it starts to get really cool. So if you want to clean this up, you can like And close all these. One other, if you have the Node Wrangler on, one more shortcut that you might want to try is if you hover over, actually I think you have to have it selected, but if you hit the M key, it like mutes it. That's how I remember it. Yeah, you have to have it selected, but it sort of like turns it off and turns it back on if you press the M key. Okay, so one final thing here. So let's say you're wanting to do this like a bunch of times. This is kind of where procedural comes into play here. Let's say you're the kind of person who's doing lots of different like mountainscapes as part of a project or part of your art or something like that, and you want to be able to do this multiple times. So we can save this, obviously, as I mentioned, but we can also like group this to be just kind of like one function that always does the same things. But you can signal specific variables that you can input into this function. So for example, let's say we're happy with all of the other like bits of this, and the only thing that we're ever going to want to change if we were to do this in the future is the random seed, is this W value. Otherwise, it's like, yeah, I like having kind of some flat low ground, but I also just want to have mountains that like aren't too high. Like if you were designing, I don't know, video game levels or something, like this reminds me of like World of Warcraft, like the Outlands or something. So what we can do, so group input, you can connect any socket to your input here. So like, I'm going to take this W and plug it into this. You can see that there's like a little like ghost socket here on the group input. I'm going to take the W and I'm going to plug it into that here. And so you can see that now there is a W input into the scene. And now on this modifier here, you can see that this value is here as well. It's this 9.2. And so what we can do is you can select all these nodes here and Control G to group them together. And this is a node group basically. And then you can hit the tab key, and it now like simplifies the whole thing into one little chunk, and you can rename this too. Like this can be called like what do you know? This is called like the landscape generator. Cool. And so then we've got your W input in here that you can change right here like this. Or like then you can take it another level deeper. Like maybe you have another node in here that you input, I don't know, another texture. You have like another like noise, and you plug that into there, and then you manipulate it this way. I don't know. Oh, but see now I'm getting a little crazy with it. Anyway, and you can just change this value right here. You can add something else into the scene. We could add something like a torus. You can G like that. And let's add our, oops, not this one, not geometry nodes. Let's add a landscape generator onto this torus. And change our W value on the torus. Oh, it's chunking my computer a little bit. I'd maybe subdivided it too many times. Let me turn this down. Ding, ding. It's also affecting that too. But anyway, you can kind of see the power here. Oh, we're also displacing the bottom. I don't know. It's kind of fun. It's kind of cool. But then you could also put a subdivision surface under. Oh, my computer's really gonna maybe freak out with this. Subdivide first, then do the geometry nodes, and right-click Shade Smooth. Maybe. Anyway. Okay. So I'll probably leave it at this because I don't want to get too far down this rabbit hole, because it's kind of a it's a niche thing, I guess, for learners. But I just want you to understand like how complex and how powerful this can be. Like it's like anything that is that you how do I describe this? It can generate. It's generative, and it can like simplify things for very large scale projects. So like some of the really interesting examples I've seen are like buildings that like if you were to, is and this is not something that can be shown in a 1 hour lecture. It's probably not even something that could be shown in 10 hours of lecture. But like I've seen people who have designed with geometry nodes like a building generator that it's like you have like a cube or whatever, and like it says like, okay, if the cube is this high, it puts this many windows or this many floors on it, and like every 1 meter that you make the cube taller, it adds another floor of windows and spaces them out evenly. And then like you know, whenever you scale your cube this way, it's adding sets of windows this way. Like so it'll automatically generate like the parts of a building, like an office building, based on the size of it. I've also seen things like if you have a curve, and it'll generate like telephone poles along this curve equally as spaced. And like if you have another curve that gets close, it'll connect the power lines between those telephone poles. And things like that. So like when I say it's generative, it sort of like uses simple things in your scene to create more complicated things. And so like this would save you, and so it doesn't save you time like up front. Like if you had one specific scene where it's like, okay, I'm making telephone poles for this one project, and there's 4 telephone poles, and they just connect to this building. It's probably not going to save you time then. But if it's like I'm working on a game, or I'm working on like some sort of like movie, like a short, like an animated movie or something, and there's a lot of this thing, like telephone poles, for example. Like there's a lot of the action in this animated movie happens on roads where there's telephone poles. Then it might make sense to like, okay, well, I'm going to model 1 telephone pole, or maybe 4 telephone poles, and it randomly chooses one of them. And then I'm going to spend the time to create this procedural generative geometry node that can save me a lot of time further down the road, rather than having to like set this up. And these are really specific examples because it can be so much more. Like I think one of the examples I said last week was like a table that like it automatically changes like the distance of the like legs on the table based on how big the top of the table is and things like that. And that's like a simpler example. I know that that Blender Guru, those of you that have watched his stuff, like he has his very famous donut tutorial, and he uses geometry nodes to add sprinkles to the top of the donut, and so it's generative. It's creating stuff, creating mesh procedurally. So if this is something that like is like making things click in your brain, go on YouTube and just search geometry nodes, and you'll find some really cool stuff. I saw another one that was like a 45-minute tutorial, and it was a guy who was like using geometry nodes to create grass and like rocks on a landscape. So yeah, if you're into it, look it up, because not everything has to be like hand modeled. You can And this is a relatively new thing with Blender too. Geometry nodes in its current state was a vast improvement from what they had before, and it it only came out like in Blender 3, which was just about a year ago. All right, so a little shorter one today. Let me just pull up the schedule real quick. So this is week 12. Next week is a little bit heavier topic. We're going to talk about compositing, which is sort of like I feel like a good kind of thing to finish with in the modeling class. Well, not finish, but like just kind of. It is good for finishing your renders and projects and stuff like that, doing some nice compositing. The week after that, so compositing is week 13. Week 14 is the week of Thanksgiving, so nothing that week. Week 15, we're gonna talk about different 3D modeling software and like why you should maybe start to like think about learning another piece of software, maybe. That's week 15. Week 16 is sort of like the final things that you maybe wanted me to cover / my like career advice spiel. And then after that, your final project is due on week 17. And that's the end of the semester. So you only have 3 lectures left for me. So obviously next week we're talking about compositing, but if there are things that you want me to cover briefly and I haven't yet, or maybe something that I promised I would and have forgotten about, please let me know, because we've only got a couple left. So your only things are to finish your 1 hour number 6, which is the bowl of anything, and also your assignment 3, which is to put a model in the real world. And then obviously I I need to talk about your final project. Starting today, you can begin working on your final project. Your final project is due on Monday, December 12th. We will before 6 p.m. because we are going to Zoom together and share our final projects. This should be something that is, I feel like I'm a ghost right now. This should be something that can be a focal point of your portfolio and your reel. So you've got over 1 month to complete your final project. Obviously, wrap up your other things if you haven't done it yet. Spend your first week or so just coming up with ideas, finalizing your ideas, looking at reference images. But I want it to be something special, and I want it to have like a super slick render. Because like that's what people want to see. People don't necessarily want to see like all of the details of your mesh in a Blender file. We want to see just like a super clean, nice render without the gray background. So like great lighting, great materials, just showcase your skills that you've picked up in modeling. And so I want like, so it can be a variety of things. You could model like one very detailed thing, like maybe it's a product or like a vehicle or something that is like has lots of nice detail, or it can be something on a larger scale. Like I think about the splash screen in Blender 3.2. Is that what we're on? I think so. Here, hold on. Don't save. Let me open this up. This thing here. Obviously, like this. Oh, we're on 3.3. This is like very far away. Here, let me even make this bigger for you. You know, I don't know if you remember when I opened this up, because you can look at these project files, but like there is a lot of detail in here. But when you get close to these buildings, it's just like a rectangle with a triangle on top. But you know, they have lots of different things, and it's a very cool effect to like be up this high. So like maybe you want to try to do something similar to this, that it's like a large scale thing and there are details, but not like an absurd amount of details. Anyway, you get what I'm saying. So begin like officially, you can start working on your final project. And there's not, other than your assignment 3, which is the put a model in the real world, and your last 1 hour thing, you won't have anything else the rest of the semester. Many of you have other things that you still need to finish up, so make sure that you're finishing those up as well. But otherwise, just spend time on your final assignment. That's what I really want you to do. Like everything up until now has just been like practicing, using different skills, using different techniques, learning about different parts of 3D modeling. But now it's like I want you to spend the time. Oh, and I suppose I need to show you the point total. Okay, here you go. Showcase your 3D modeling skills in a portfolio-worthy project. I'm looking for 10 plus hours of effort. This is worth 30 points. 9 points for your level of effort. 9 points for variety of skills used. 9 points for a super slick render. And 3 points for an on-time submission. So when I'm talking about level of effort, 10 plus hours. So like you could include, research time, planning time, idea gathering time. But like if you like start modeling and you're like done modeling after an hour, I'd say then you should add some more. Not necessarily more to your one model, but maybe put your model in an environment that has models, things like that. 9 points, variety of skills used. So this is across all of your 3D time here at Hennepin Tech, so including basics and whatever. But it's like, obviously I want to see some modeling. I want to see some materials and textures. I want to see maybe you have curves, maybe you have particles, maybe you have like some modifiers, maybe you have some physics, maybe you have some geometry nodes, maybe you have just showcase a few different skills at least, please. 9 points for a super slick render. So the render again is like key to this. Like think about the composition, think about where your camera's going to be, think about your lighting. I don't want it to be like super dim and dark, and I don't want to see the gray world environment. You maybe use an HDRI, or maybe it's black and you're using really great lighting. Or maybe it's white and you're using like a white thing. And then obviously meeting the deadline, which is December 12th, which is 1 month and 6 days from now. Okay. You can do this. You're doing good. You are skilled and you have learned a lot. And you have lots of time to do this. Hopefully you have stayed caught up on other assignments and things, so you've left yourself plenty of time to do this. If you're feeling nervous, please let me know. Also, again, if there are things that you want me to cover these last few weeks that you're dying to know about, or that I've forgotten that I was going to talk about, please just let me know. Email me. Otherwise, that's it for week 12. Tally ho! Goodbye.